Alright, today we're going to be looking at extending the properties of exponents to include all integer exponents. Alright, so we're going to look at properties of exponents. Now our essential question today is going to be 1 milliliter of water contains about 3.33 times 10 to the 22nd molecules. About how many molecules are in a liter, well, in half a liter bottle of water? And then your answer will be in scientific notation. So at the end of the lesson, I want you to come back and do this. Alright, now in this lesson we only really have one vocabulary word, or actually it's two words, scientific notation. Now with scientific notation is how we write really large or really small numbers. And a lot of times it's used in science, and that's why it's called scientific notation. Now the important part is you'll have a number, and then it'll be times 10 to the n. Now on your calculator sometimes it uses a different little notation, depending on what type of calculator. But the important thing to remember here is that C has to be between 1 and less than 10. It won't be 10, it'll be something less than 10 when you write it out. And then we have our properties of exponents here. We have the power property. Okay, when we multiply powers, we actually end up adding the exponents. Power of a power, when you have a power to a power, you end up multiplying the exponents. Okay, then the power of a product. Now this means you have two numbers multiplied together, and then you have a power on the outside. The power affects both things before you multiply them together. Then negative exponent, if you want it to be positive, you write it underneath. But your base, in this case, which is a, cannot be 0. And then 0 of an exponent, now this is important, anything with 0 power is 1. Okay, anything with 0 power is 1. Then quotients of powers, here we have m, a to the m divided by a to the n, so we'd actually end up subtracting. And then power of a quotient, here we have a number divided by number, the power affects both of them. So we're going to raise them to their power before we would actually divide. You may want to jot these down. Alright, we're going to evaluate this. Now, what I would do first is, let's bring this negative. If it's negative underneath, it's positive up here. So I'm going to rewrite this as 3 squared to the third times negative 4 to the third. Okay, now here we're going to end up with 3. We're going to use power of a power property, and so we end up with 3 times 2 times 3. So 2 times 3 gives us, that's going to end up being the 6th power. Now here 1 would be here if you wanted to write it in, so you could write it like this. But we're going to end up with negative 4 to the third power. Negative 4 times negative 4 would give us positive 16 times negative 4 is going to give us, well, I'm going to go ahead and write it this way. Just for simplicity for right now, I'm going to write it out like this, and then I'm going to do the power in a second. Okay, so I got 3 to the 6th power, which is going to be 729. Negative 4 times negative 4 gives us positive 16, but then we multiply it by negative 4 again, which gives us negative 64. Okay, and so then when we multiply these two together, we end up with negative 46,656. Alright, let's look at part B example. Alright, with this, we're going to start out with the power of a product. So we end up with negative 3 squared, okay, then 2 to the 5th squared. Okay, so that would be power of a product property. And then we're going to do power of a power here. So we end up with negative 3 squared, which gives us 9. I'm going to go ahead and do that. Okay, and it's positive because I have a negative times a negative. Then here I'm going to end up multiplying this. So I'm going to put 2 times 5 times 2. Because I'm multiplying my exponents here for the power property. Okay, and then so we end up with 9 times 2 to the 10th. Okay, and then we take 2 to the 10th, multiply it times 9, and we end up with 9,216. Alright, now with this one we have this negative exponent. If we want to get rid of the negative exponent, we're just going to flip it. So we end up with 10 to the 8th over 10 to the 5th. Okay, and so we got rid of the negative exponent. We could have multiplied the negative through and got negative 5 over negative 8, and then we'd end up doing the same thing. Okay, so now we're going to end up subtracting the exponents. So we end up with 10 to the 3rd power. And 10 to the 3rd power is going to be 1,000. Alright, here we're looking at the volume of concrete that was used to construct the Hoover Dam is about 3,325,000 cubic yards. 1 cubic yard weighs about 4,050 pounds. How many pounds of concrete we use? So basically what we're going to do is to find the number of pounds. It's going to be equal to the weight per pound, weight per cubic yard. Okay, times the number of cubic yards. Alright, so we know that this is how many, that each one weighs this much, and this is how much was used. Alright, now keeping with the lesson, we're going to use scientific notation. So to write this in scientific notation, I'm going to move this up 1, 2, 3, 1, 2, 3. So it'd be 3.325 times 10 to the 6th. Remember, in scientific notation, you want one number in front of the decimal, okay, and we keep all 9 zeros. Now we would keep zeros that came between numbers, but the zeros at the end we don't keep. Okay, I'm going to go ahead and write this in scientific notation too. So 1, 2, 3. So 4 times 10. Oh, sorry, I got to use 4.05. So this is an example where we keep the 0 in between, times 10 to the 3rd power. Okay, now using what we can do here is go 4. We can multiply this times this. So we multiply the numbers in front together, and then we're going to add the exponents because we're multiplying. So we go ahead and multiply these numbers together. Okay, so when we do that, we get 13.46625 times 10 to the 9th. Now we want to keep this in scientific notation. Alright, so we're going to move the decimal place there. We moved it to the left. Anytime we move it to the left, we're going to add to this number. So we have 1.346625 times 10 to the 10th would be our final answer in scientific notation for this. Alright, so let's look at some of these. Now, with this, we're going to have to use our property rule first. So it'd be 3 times 2, so we end up with 2 to the 6th power, 5 to the 3rd power. Okay, and so what we're going to do is take 2 to the 6th power, and then 5. Alright, so we end up with 64 times 125, and then when we multiply that together, we end up with 8,000. Now we use the power of a product property and power of a power for that one. Alright, and then number 2, we have these. We have negative exponent, which we could go ahead and deal with, but I'm going to go ahead and deal with it this way. So that we end up with 7 squared, so we end up with 49. Alright, I'm going to go ahead and wait till the next video to do the rest of them. So part 2 will start off with questions 3 and 4.